Brian.
Thank you.
So next up, we're going to do something that we've never done before. We're going to bust out this table here and actually do a live collaboration experiment with all of you in the keynote audience. So if you wouldn't mind bearing with us and getting out your mobile device or your iPad. Next up, a gentleman named Michael Wu, who yesterday conducted our analytics workshop, is going to use open source social network analysis tools. And he's going to explain how this is going to work, and then we're going to actually do it. So looking forward to seeing how this thing shakes down. Please help me in welcoming Michael Wu.
Good morning, everyone. So, as a scientist, I've done many experiments. And this particular experiment, I've done several times. But I must say that I've never done it in 30 minutes. So let's see where I end up today. So this is an experiment where you, as an audience, will collectively collaborate on something. And something is to take notes on this particular talk. Okay? And I know most of you take notes anyway, right? So instead of taking notes on your iPad or iPhone, I'm just going to ask you to tweet out those notes. And to collaborate, you simply retweet anything that you see that's noteworthy. So you may want to open a new search stream on your whatever client that you like, and basically watch this hashtag. So we're going to use this hashtag E2EXP, stands for Enterprise 2.0 Experiment, instead of the E2Conf. So that is in a way that I'm going to use this hashtag to collect the data at the end. So if you don't use this hashtag, I would not be able to collect data on you. Okay? So let the experiment begin. So this is the agenda today. SNA stands for Social Network Analysis. And I'm going to cover some basic stuff there. And then I'm going to look at two applications, one for influencer identification, one for internal collaboration. And then I'm going to show you some tools and analyze the experiment today. All right, so let's begin. So in order to understand what social network analysis is, we must first understand what is a social network. Well, what is a social network? Social network is basically a collection of entities plus the relationship among them. Okay? So we're talking about social network, right? The entity that we are interested in is typically people. Okay? And in the SNA lingo, these are typically called nodes and vertices. And these relationships can be anything that we care about. They can be friendships, colleagues, and can be kinships, or just communication. Okay? And in the SNA lingo, we call this edges and connections. All right. So now you know what a social network is. What is a social graph? Okay? Social graph is basically a diagram consists of nodes and edges that represent the social network, right? And the key thing that I want you to take away is that one social network may have many, many social graphs, right? So my social network consists of essentially my friends, my colleagues, my relatives, right? But they are actually shown up in many different graphs, right? My friends probably show up on my Facebook graph, and my colleagues actually may be on my LinkedIn graph. So let me just illustrate this by a very simple example. Okay? So let's say I have a really simple life. I only have 7 friends in my life. That's my social network. And for example, like Joe and Phil are colleagues of mine. We work at Lithium together. And I also worked with Jack and Ryan before. And also, Ryan and I also work in the same job in 2 places. Okay? So we work with both Jack and Don, but then Jack and Don are actually not coworkers with each other because they actually work in different places, right? So this could very well be my LinkedIn graph. Okay, this is one social graph. So the relationship that's represented by these edges, right, are coworkers. Right? Now I could actually create many other graphs. Right? I actually love to drink beer. I love Belgian beer. So everywhere I go, I drink with people. Right? So I drink with Doug, Adam, and Ryan, and but somehow Doug and Ryan don't get along. So there's they actually never drink with each other. So you can see that they are not connected there. Okay, so it turns out that Phil and Jack also drink together, but they're the big boss. They never drink with us, right? So this could be my beer buddy graph, right? So the relationship, the relevant relationship that's highlighted by this particular graph is we drink beer together. That's the relationship, right? So that's the relationship represented by these blue edges, right? Right. I also love to play badminton. So everywhere I go, I play badminton with somebody, right? So I play with Joe, Jack, and Don. It turns out that Ryan also has played with, these two other people, right? But they're pros, okay? They actually play in tournament, right? So we actually never play with them, right? As you can see there, these two graphs are distinct. So this could be the badminton power graph, right? So the relationship of relevance is we play badminton with each other. Okay, so notice what happened. I have just created 3 social graphs from this very simple social network of mine. One social network created 3 social graphs, right? Okay, and I could also create another one, right? This is what we call the Facebook social graph, right? Facebook simply collapse all those relationships and call them just friends. And this is why they get into trouble, because our relationship has many different contexts. Some of our friends are college roommates. Some of our friends are kindergarten schoolmates, right? And that's why Google created the notion of a circle to characterize each one of those different relationships. All right, so by specifying what relationship the edge represents, we can actually get a very different graph that you've seen, right? We get 3 very different looking graphs by specifying the relationship that's represented by the edge. All right, so now, what is social network analysis? Basically, it's 3 steps. Okay, first is you construct the social graph that contains relevant relationship that you care about. That's first step. Okay, so LinkedIn has this really nice in-map application. It's basically network mapping, but that's just the first step. What they didn't do is that they did not do the second step. Okay, so the second step is basically the analysis of this graph by computing network metrics on these nodes. Okay, so we could compute some metrics on these nodes, such as the degree centrality. Okay, so the degree centrality simply says that the number of connections that you have. So this guy has 4 connections. This guy has 1 connection. This guy has 3 connections. That's all it is, right? So that's the computation of metrics. Right? So this is a very simple metric, the degree centrality, but we can actually compute something more sophisticated. I'll show you later on. Okay. Now, the third step is, well, you interpret the network metric to gain some insights, intelligence of how the social network actually works, right? So because I've computed these metrics, now I can say something about this network, right? For this network, on average, most people have 3 or 4 connections, right? If I don't compute those network metrics, I would not be able to say that, right? Okay. Now, the most important thing on reading a social graph is to find out what relationship is being represented by the edges. And you don't make any inference or conclusion about anything based on the graph which is not explicitly represented by the edges. That could be really dangerous, right? If I'm trying to make an inference or conclusion about how many people I work with using the Facebook graph, that's not going to work, right? It's going to give you a very misleading conclusion. Okay, so that's some basics on SNA, and so I'm going to talk about one application now, is using that to identify influencers. So despite the fact that we generate a lot of data on social media, no one actually has data on who actually influenced who, right? No one has that data, right? So we need a model. Basically, we need to build a model. So this model is the model that I built, and it's actually validated. And I talked about this yesterday in the workshop, which is, I talked for 4 hours, so my voice is a little coarse. I apologize. So this is a model for influence propagation, right? It asks the question of what does it take for the influencer's influence to propagate to the target? And by analyzing 10 years of data at Lithium Technology, we actually identify 6 factors that's of critically important. Okay, first is credibility. Right? If I'm not credible here, I can't influence you. Because why? You're not going to trust me. Okay? But on the other hand, even if I am credible, if I don't talk to you, I can't influence you either. right? So the second factor is bandwidth. I have to talk, and I have to talk a lot. Okay? Now, the third factor we find is that relevance. If what I say is not relevant to you, then I can't influence you either. If you're trying to buy a camera, and I'm here talking about analytics, you're going to say, that's very interesting, but I'm probably not going to influence your purchase decision on purchasing a camera. Now, the fourth factor is timing. This is actually very critically important, right? During every consumer's purchase journey, there's only a small window in which they are susceptible to influence, right? This is the time when you are about to decide to make the purchase. Once you make the purchase, it's too late, right? If I'm trying to buy a new laptop, I may do research on a couple of weeks, and then I'll buy the laptop. After that, you can't influence me anymore. I already bought the laptop. Okay? So fifth factor is channel alignment. What that means is that the influencer and the influencee better be on the same place. Right? That works both online and offline. If you're trying to influence people on Facebook, it won't help you if you find an influencer on Twitter, unless it's also on Facebook. Right? So same thing. If you're trying to if you have a marketing campaign in Boston, right, it's not going to help you if you find an influencer in San Francisco. His influence is not going to be able to propagate here, unless he comes here. Right? So, and the last factor is what I call confidence. Okay, this is what other people call trust. Okay, regardless of whether I have bandwidth, credibility, relevance, or timing, if you don't trust me, then I'm out of luck. I can't influence you, right? So the interesting about this model is that you have to have all 6 factors in order for the influencer's influence to propagate to the target. If you're missing any one, then you break the chain, right? That means the influencer's influence can't propagate to the target, and then you don't have influence at all. It's not the case that you just have less influence. You actually don't have influence at all. All right. So let's take a look at the importance of content relevance and timing. Okay? This is a real social graph, right? Each one of these gray edges represents a friendship, right? So we know that each one of these dots is a person. So this guy is this guy's friend. This guy is not this guy's friend. That's all it's telling you, right? And I have made the size of the dot proportional to the number of friends they have. So this guy actually have lots of friends. This guy have fewer friends, and these guys have very little friends, right? Probably just 1 or 2 friends, right? So let's say if you are a brand manager at like Apple, and you want to find the influencer for the Apple iPhone 4. Who do you think the influencer is? Well, normally you would say it's probably this guy, Pop Guy, right? Just look how many friends he have. But I didn't show you all the data. We can actually track all the conversation each one of these person have with their friends, right? And I could color the conversation that actually mentioned Apple iPhone 4 in red. So if I do that, look what happened. Now you change your mind? Okay? So even though Pop Guy has so many friends, that's not the relationship that you care about. Right? He may be influential in something else, but not the Apple iPhone 4. He may be influential in sailing or cars or his motorcycle or something else, right? That's what he talks about with his like group of friends there. But he doesn't talk about Apple iPhone 4 with his friend. Not very much, right? So now, who do you think the influencer is? Probably is this fangirl and WizKid, right? But I also did not show you all the data here. Every one of the conversation we track, we also have their timestamp. Right? We can actually color the conversation with a lighter shade of red when they're further back in time. And if I do that, look what happened. Fangirl was an influencer. She was 6 months ago, but not anymore. Okay? So if it takes on average, people, the average time it takes people to do research to buy an iPhone is about, like, say, a week, then she's not relevant anymore, right? If this is a very sophisticated product, say a car or a house, and it takes people more than 6 months to do research in order to make the purchase, then yeah, she may still have some influence. But for some products, simple thing like an Apple iPhone, she's no longer influential, right? Okay, so that's the importance of relevance and timing. So let's construct a unweighted influence graph. So each one of these edges now represent all those 6 factors. Only when you have all those 6 factors present, you connect the 2 people. Okay? So we could look at this in what we call an adjacency matrix representation. Okay, so this simply says that, okay, so A is connected to B, C, D, E, not F and G, H, not I, J, and not K. Okay, you can look at that graph to verify that. Okay, you could do that for every single person on this graph. Okay, and you could do that for everybody, and you just fill out that matrix. Once you have everything in that matrix form, as a data scientist, you're very happy. That's heaven for you. That's heaven for me. Okay, and because you could compute something very easily. For example, you could compute the degree centrality, which is the number of person that you connected to, which I just explained earlier, right? You just do that by simply summing over the rows, right? So you can see that A is actually sums up to 6, and he has 6 connected to 6 people. If you do that for everybody, then you know how many people everyone is connected to, right? But this is actually a very simple computation. We could actually do something a lot more complicated. We could compute something called the eigenvector centrality. Okay, the eigenvector centrality is actually very much similar to the Google's PageRank. Okay, if you think about how do Google solve the problem of finding the most authoritative web pages on the web? Well, what is the World Wide Web? The World Wide Web is basically a bunch of web pages, and they're connected by hyperlinks, right? And Google solved this problem by their PageRank algorithm. Well, if you stare at this problem long enough, you're going to say, well, this is actually exactly the same problem that we have. Mathematically, it's exactly the same, right? Instead of pages, we have people, we have users, right? And instead of hyperlink, we have communication and interaction, right? So the problem of finding the authoritative web pages is exactly the same as finding influencers in a network. All right. So what is this eigenvector centrality and PageRank? It's really simple. Okay. So if I label all the users who have 10 or more connections here, who do you think is the influencer? Who is the most authoritative here? Most of you would probably think it's this guy with 29 or 32 connections, right? Well, that's because you've never seen the underlying network structure. If I actually show you how they're connected, you may change your mind. Okay? You may think that, well, now you think, well, probably this guy is more influential, right? Because, well, even though this guy has 32 connections, they're all losers that nobody cares about, nobody connects to them. So, right? So, OK. So now look at the next one. OK, so I'm going to switch back one and then back to here. OK, so I have not changed the number of connections that each one of these nodes have, right? But look what I have created. I have created this guy right here, right? So this guy is what we call a connector or bridge, a network bridge, a boundary spanner. There's actually many names for them because they actually arise in many, many disciplines of science. Okay, so they actually do exist. Okay, so this is actually a real social graph of a community with 4 sub-communities. Okay, so this guy right here, he's actually connected to all 4 of these sub-communities. But if you look at how many connections you actually have, you only have 10 connections, right? If you don't compute this betweenness centrality, is what I'm talking about here. This betweenness centrality, okay? You will never find this guy, okay? You will always, this will be a tiny dot here that you will miss completely, okay? So now, so basically, that's how we use to construct the graph. Once we constructed the graph, we can actually compute, all the different metrics, the network metrics, and then quantify who is the influencer in the network. Now, let's look at another application on internal collaboration, right? So that comes down to a tug-of-war between 2 things, okay? The relevant relationship that you care about and the data that you can get your hands on, okay? So the relevant relationship that you care about is usually something related to collaboration, right? Something such as collaborate on some projects, you have produced some product and services together, or you designed something together, or co-created something, okay? But you don't always have data on that. The data that you can actually get are these type of data, right? You have communication data, you have emails, phone calls, IMs, instant messaging, right? SMM messages. And you have meetings, calendar data, right? And you also have content usage data. For example, on SharePoint, you can actually track who has downloaded whose content, who has edited whose content, who has shared somebody else's content. Those are the data that you have. Okay, so let's look at a very simple hypothetical example of, say, like 8 people, right? So if I actually look at the criteria of people who exchange 1 email a day, right? Then within this network, everybody have exchanged at least 1 email a day, right? If I make that criteria more stringent, say like 5 emails with at least one reply, then only some people are not in the network anymore. Okay, they're actually in this flashing part of the network. If I make it even more stringent, then the network gets smaller. If I make it too stringent, there are actually too few people on the network. Then basically nobody's connected to anybody else. So let's use the third criteria here: 5 emails with like more than 5 replies. Okay, so let's use that. If we use that as a criteria, then this is the network that we get. And if I have other data, such as instant messaging, right? Say if I use that as a source of data to gauge how people collaborate, then we know that these people out here, they don't collaborate with instant messaging here, right? But these groups do. So let's see how much they collaborate. Like if I use 1 IM per week, you get that graph, and if you use 5 IM per week, you get a smaller graph, a subgraph of that, and you get, if you increase this criteria, then you get even a smaller graph. Okay, so you get that. So let's use that as a criteria as well. Okay, so we get the red. These are people who have exchanged at least 5 emails a week with 5 replies and have 10 instant messaging sessions per week. All right. How about meetings? Okay, if I have the simple criteria of 1 meetings per month, then everybody in this group has 1 meetings a month. Let's increase that criteria again. Let's say 3 meetings, then now your graphs get smaller. And if you increase to 5 meetings a month, then the graph gets even smaller. Now, let's use the last one as my criteria. Okay, so now I'm just going to actually make this a little more visible to you because these graphs overlay on each other. Okay, so if I said if collaboration means that I have to exchange 5 emails with at least 5 replies, and have 5 instant messaging sessions, and have 5 meetings a month, if that means collaboration, then only these 3 people have collaborated with each other, right? Because these are the only 3 people who have the blue, red, and the yellow graph connecting them, right? Okay, so basically, take the blue, green, so the blue, red, and yellow, and put them together, you get the green graph, right? And that's what I mean by collaboration. Okay? Now, for different company or different enterprise, you may have different criteria, right? And actually, if you look at the graph here, different roles actually collaborate different ways, right? For a product team, like this database guy, the product manager, and the Java developer, collaboration means you have lots of IM with long email threads, right? That's what it means. But for executives and managers, it means something completely different. It means that people have lots of meetings together, right? So those are represented by the yellow graph there. And so what I want to say is that email or any single data source is usually a poor indicator of collaboration, right? I may email you a lot because I'm your friend, right? But if you have several or many of these criteria collectively together, just like the influence graph that we built, then we could infer collaboration pretty well, right? So in summary, you must define what collaboration means, right? You have to define that in terms of the data that you actually can get before you can actually quantify collaboration. And once you could define what collaboration means in the data that you can get, then you could construct a collaboration graph, right? Because each one of these edge now means collaboration, right? And collaboration means whatever criteria that you set, right? Now you could compute network metrics and quantify collaboration. OK, so now I'm going to actually switch and go to this tool right here. Actually, not quite. So there's some tools I'm going to show you. So the first is open source social network analysis tool. So these go from really simple to use to something really complicated to use. So this one is really easy. And these Kayak is actually very hard to use. Okay, but the trade-off is that you get power and scalability. These actually works on millions of nodes. These works kind of on smaller networks, like thousands or tens of thousands. Okay, and if you don't want to do SNA yourself, you want to develop SNA tools. These are the public open source library that you can use. This is the one that I actually use, Boost, the boosted graphic library. It's in C, and if you don't like C, you could also use Java. Okay, so that's if you want people to develop SNA tools for you. All right, so let me actually get on to this analysis. Okay, so hopefully all of you had tweeted with the hashtag of E2EXP. Okay, so I'm going to import this data. So this is actually no Excel. It's written as a kind of a creation of one of my friends, Mark Smith. And so I'm going to search for E2EXP. And I'm going to actually search for a lot of people, okay, the maximum that we have. And let's actually add a tweet column there. Okay, so now it's going to go out to Twitter's search API and collect all the data you have generated. Okay, and so that's pretty quick. That's good. So now I have essentially, let's wait for a sec. Okay, we have all the people here now. Okay, so actually, I could actually show you the graph for now, and so this is what it will look like on the right-hand side. So you can see that these are. See if you can find your names there. Okay, it's kind of small, so it's actually not very visible, but I'm going to change that. Okay, so I'm going to actually go to the vertice here, and I'm going to change the shape to actually an image. Okay, and once I do that, I need to refresh the graph. And this is going to be a pretty slow process because it has to go out and collect all the data from Twitter. Actually, it's not that slow. Okay, it's actually pretty fast. Good. Okay, so this is what we have. So I'm going to scale this down a little bit so we could all see each other. So these are the people who tweeted the experiment. Okay, now they're all the same size, right? So it's not very good in indicating who's actually collaborated, who's influential, right? So we can actually do some metric computation. So we talk about degree centrality, you know what that means, right? And we talk about betweenness, and we talk about eigenvector, and we talk about page rank, right? So we just calculate all those. So let's do that. And once I do that, I want to fill the column. I want to change the size of each one of the vertices by mapping the size of the vertice to the, let's say, let's use the out degree. Okay, out degree versus in degree is basically how much you tweeted versus how much you being tweeted. Okay, so out degree is how much you. So let's find who is the biggest tweeter here. Okay, if we do that, oh wow, look this, interesting. We got some winner here. Okay. All right. So let's take a look at who's being tweeted the most. Let's look at the in degree. So before I do that, I'm going to lock this graph so these things don't move around. So you can actually see. So I lock it. Okay. Now I look at in degree and I refresh. Oh wow, I'm being tweeted most frequently. Okay, so that's not fair because I'm talking. So right. Okay, so let's. Okay, this is interesting. So we can actually filter out this guy. Okay, so let's do some dynamic filtering, and let's filter out the one person who is being tweeted the most, me, and then we can see who else is the winner here. Okay, so. Pretty interesting. So there's actually quite a few. David Carr here, Ray Wang, here Dean Hinchcliffe is being retweeted a lot. Okay, so this is actually very interesting. So we can actually see who is influential in this network. Now let's see if we can actually understand who's collaborating with who. Okay, so let's do that by actually filling. So let me unfilter that back. So so this is very nice. You can actually filter the people from the bottom and up. So these are the smallest nodes. If you, so these are the people, essentially the top people who's being retweeted, okay, as they come out. So, so let me just turn this off. And now I want to remember we have talked about the edge weight, right? So the edge weight essentially represents how much you tweeted or retweeted another person. So I'm going to make the width of these edges proportional to the edge weight. And I'm also going to make the opacity proportional to the edge weight. So I'm going to fill that and see what happens. So very interesting. So let me actually use a different kind of layout. So I will have to unlock this, because I lock it, it's not going to change anything. So now if I refresh the graph, okay, so you can see that, well, let's do a few more iterations so it looks a little better. So we see that some people actually like tweeting themselves. Okay, so let's try to remove that. So we can actually change the visibility of each one of these graphs. So let's say equal if vertex 1, oops, where is it? If, so equal if vertex 1 is equal to vertex 2, then I want to make it invisible. I want to set it to 0. Otherwise, I want to leave it 1. Okay? So now if I do that, all those kind of self-tweeting circular thing, these self-tweeting circular loop would disappear. Okay, so let's do that. And I'll have to refresh the graph. Okay? Now, you can see who actually collaborated with who. So let me lay out with a few more iterations. Okay, so this actually, let me use a different layout, see if, okay, and then switch back. Okay. All right, so you can see that, these people tweeted me a lot, and then, this person actually been retweeting this person quite a bit, right? So all this you could get from social network analysis. So you can actually quantify and see visually who has collaborated with who. So this is all I'm going to say on this experiment. Thank you very much. Okay.
Cool. That was really cool. Appreciate it. Thanks all for participating. I think it was a success.